Earth's modern climate is the consequences of natural events that have happened over the past 66 million years. To gain a perspective of what's happened in that period of time, we'll take a quick look at our present state. Currently, the average temperature of the Earth, which is depicted by this blue line here, the average temperature today is around 57 degrees Fahrenheit. I'm going to point out that we are currently in what's geologically known as an ice age. An ice age is considered a cold period when there are permanent ice caps on one or both of the poles. Currently, there's an ice cap on Antarctica and another one on Greenland. Well, one constant about Earth's climate is that it's always changing. As denoted at the top of this panel, Earth's average temperature is approximately 1 degree Fahrenheit warmer than it was during the 1960 to 1990 average period. As the Earth warms, the ice caps melt accordingly. Global sea level has risen approximately 8 inches since 1900. Now there is a very close correlation between Earth's temperature and the amount of greenhouse gases in the atmosphere. The primary greenhouse gas is carbon dioxide, or CO2. As indicated above, the amount of carbon dioxide in the atmosphere is currently measured at 410 parts per million. That's a really small percentage of Earth's atmosphere, which is primarily made up of oxygen, about 20%, and nitrogen, close to 80%. However, back in 1900, carbon dioxide was measured at only around 280 parts per million. The primary increase in carbon dioxide from 280 in 1900 to 410 today is attributed to humankind's burning of fossil fuels and mankind's use of agriculture. These human-induced additions to carbon dioxide are called anthropogenic emissions. As we travel back in time, we'll have an opportunity to see how temperature, carbon dioxide, and sea level values vary as time changes. We'll also have an opportunity to see how plate tectonics have rearranged the position of the continents on the Earth. We won't see much change in this until we get way back in time, around 66 million years ago. The time period indicated in these panels we're going to be looking at will be designated by these blue panels. Here in this example, we've positioned our time, which has been marked by this X on the left side here in this block of time, from 0 to 1000 years in the past. Also, you'll note that this particular panel covers 20,000 years from the left to the right. I'll also point out that the temperature chart here is valued by a scale here. This black line you see here runs through the 0 points on the temperature scale. 0 point meaning that is at today's value, which is 57 degrees Fahrenheit. The numbers going up here plus 20. These are again in Fahrenheit and denote variations above today's average. Again, the average was 1960 to 1990. The same holds true for these negative values, as you can see from this blue temperature chart. As we go back in time, when we go back towards the last ice advance called the glacial maximum, Earth temperature dropped quite a bit. Now carbon dioxide values are determined by this gauge here. Approximately 20,000 years ago the value was 280 parts per million, but it's been mostly flat ever since, until the last several hundred years, where it has spiked up to 410. Finally, sea level is indicated in this black curve. Here the chart value is at 0 and the scale for sea level goes down here to minus 140. These are in meters, not feet. And you can see that as we went back in time towards the last glacial maximum, when the Earth was real cold and there was massive ice sheets all over North America, sea level had gone down enormously. And if I bring up a little tool that I can use to measure where we are on the right side here, 20,000 years ago sea level was about 122 meters lower than today. Here I've navigated to the next panel in this project. The X is sitting at 20,000 years in the past. The temperature graph here is this blue-black thing here, and this particular panel will end at 1 million years ago. On the far right we have a CO2 curve that's up here. You can see the variations. And we also have a sea level curve, that's this black one here. Again, the temperature gauge is here. The CO2 gauge has been moved over to the right end, that's here. And the sea level gauge is here, going from 0 up to plus 20 meters and 0 down to minus 140 meters. Here I've advanced the position of the time marker, that's at the X, to 800,000 years ago. We're looking at a different carbon dioxide graph. This one is pretty worthless for this particular panel, and that's because the time scale here, that's this almost 1 million year coverage here, is represented on the CO2 chart by this little red splotch here. That means that the CO2 values that pertain to the temperature time period is represented by this blue smear here. So the CO2 graph is for all practical purposes unusable in this time span. Here I've advanced us to the next panel in this project. The temperature curve is this black squiggly line you see here. We do have a CO2 graph, but again the CO2 graph that applies to this temperature curve over this period of time, which is about 4.5 million years. That is to say, we're going from 1 million years ago on the left to 5.5 million years ago on the right. That time frame and temperature is represented by this red spot here. So the CO2 line you see above that is the one that pertains to this panel. Again, not very useful, but you can see a general trend in the CO2 line here. I've advanced us to the next panel. We're now at 5.5 million years in the past, and at the far right side we'll be at 66 million years ago. Here we have a sea level line, that's this red one. Here temperature is in green and we still have our CO2 up here. Because of the scale of the time frame here going from 5.5 to 66 million years ago, most of the CO2 scale you see up here is valid. The CO2 scale range is this gauge here. The temperature gauge is the same one we've been using, that's this one here. Can't see the 0, but it's right here. Again, there's the black line that marks the 0 temperature point, and the sea level gauge is over here. In this case, 0 sea level, which is today's value, is where you see this little blue line. Sea level gauge is going up to 400 meters and down to over 100 meters. I had earlier mentioned that most of Earth's modern climate is a consequence of events that have happened in the past 66 million years. Accordingly, I've navigated us back to about 66 million years ago, as evidenced by the indication of the X and the time indication here. Earth's climate was quite a bit different back then than what it is now. First thing I'll point out is how much warmer the climate was back then. Specifically, we bring this little blue line up to where the temperature curve is about 66 million years ago. Looks like the temperature was running about 20 degrees Fahrenheit warmer than today. Likewise, carbon dioxide values in the atmosphere were a lot higher 66 million years ago. It was about 1,350 parts per million compared to 410 today, or about 3 times higher. Sea level was also a lot different 66 million years ago. If we look at the graph here, sea level was running about almost 180 meters higher than today's level. Again, 0 is today's level, and this is the scale for sea level. Again, these are in meters. 180 meters is 590 feet. Finally, 66 million years ago the continents were in slightly different positions than they are today. You can see that India is not yet connected to Asia. In fact, it's out all by itself. The tip of South America is connected to what is now Antarctica, and Australia is connected to what is now Antarctica. What I'm going to do now is walk us forward in time along the temperature curve, and you can see a couple of events that will catch your eye. Number 1, around here we're going to get a big spike in temperature as well as CO2. At this temperature peak here, which is going to be close to 25 degrees Fahrenheit higher than today, there's also a peak in the CO2. But note that sea level values will keep going down. And that's primarily because as we go forward in time the continents are going to be breaking up and approaching more like they look today. So let's go ahead and move forward in time. Notice how the temperature goes up and down. And when we get to this location here, I'm going to play it back slowly. You see the temperatures going up for some reason. I'll pause it here. So somewhere between 54 and 55 million years ago temperature really spiked, CO2 spiked. I don't think anybody really understands why. If we take a look at where we are with temperature at this point in time, we're almost 27 degrees Fahrenheit above our current temperature value. Sea level has dropped quite a bit, but it's still about 125 meters higher than today's level. We'll continue to go forward in time. Our progress right now is pretty slow because I'm letting the project play automatically. Now that we're back to the normal curve, I'll go ahead and move it manually. Here's another peak, both temperature and CO2, and we'll go down here. There's another temperature spike, but notice nothing happened in CO2 according to the geological record in this chart. By the way, are CO2 values derived by looking at rocks? We'll continue our walk forward in time. Notice at this point an event happened. It says the Drake Passage and Tasmanian Seaway open up in the southern oceans. The Drake Passage is the gap that forms between the tip of South America and Antarctica. The Tasmanian Seaway is the gap that opens between South Australia and Antarctica. When that happened, it created the formation of what's called the Antarctic Circumpolar Current, which is a current that allows cold water to continually circulate around Antarctica, keeping the Antarctic continent very cold. And as you'll see, that will precipitate the start of the modern ice age. And that's because Antarctica is going to pick up an ice cap. And that's going to happen pretty soon. Here we go, around 33 million years ago. Antarctica has developed an ice sheet, and this is the beginning of our current ice age. Also, I'm going to walk the other way for a minute because I want to point out that you'll notice that India has finally smashed into Asia during this process. That also made a big difference to our modern climate, because when India did that, it formed the Himalaya mountains, which pushed up the Tibetan plateau, and that process actually caused the climate to get colder itself and to dry out because a lot of the air was forced up high over the mountains. And we're going to continue to walk forward here. You won't see much more change in the positions of the continents because they've pretty much reached most of their current position. The biggest thing remaining is that there's still a separation between North and South America, and that gap will close up at about 3 million years back in time. And when that happens, Antarctica will still have its ice sheet. Then Greenland will also pick up an ice sheet. So we're continuing to go back in time. Notice how sea levels are dropping continuously. And that has a lot to do with the fact that there's a lot more separate continents now with shorelines. CO2 has gradually been dropping from 66 million years ago to what's going to soon be the beginning of this panel at 5.5 million years. So here we are at 5.5 million years back in time. The CO2 chart that corresponds to this position on temperature is the beginning of this red bar. And if I go up here and take a quick read at the beginning of the red bar, we're looking at CO2 values here that are down somewhere to around 550 parts per million. That's quite a drop from where we started at. Here we've navigated to the next panel. Time here goes from 5.5 million years ago on the right to 1 million years ago on the left. We're going to go forward in time. There is no full panel sea level curve in this panel. That's because a chart for that time span was not available. I want to point out that the first thing you're going to notice is that the average temperature is pretty much holding above today's normal until we get to around here, which is going to be maybe 2 million years ago. As we go forward in time, you're going to see a lot of fluctuations, and the fluctuations are going to be due to the fact that we're still in an ice age. There's an Antarctic ice sheet and there are glaciers forming all over the Earth, but mostly in the southern hemisphere. The northern hemisphere does not have a permanent ice sheet yet on Greenland, and accordingly, the glaciers are not forming and advancing and retreating over North America, Europe, or Asia yet. So we're going to go ahead and advance in time, so here we go. And again, you're not going to see any material change that looks obvious in the plate tectonics position of the continents, because everything is where it's supposed to be, except there's still this gap between North and South America, and that's going to close up when we get to around 3 million years ago. Notice all the fluctuations. That's due to the advance and retreat of glaciers in the southern hemisphere. Also notice right about, let's say here, 4.5 million years ago, the Isthmus of Panama is starting to close off. And once that does close off completely, it's going to create what we now know as the Gulf Stream current. So we're going to continue to go forward in time, though we still have just an Antarctic ice sheet, by the way. The CO2 that corresponds to this whole range here is that which is over top this red splotch. And you can tell that the CO2 is gradually going down from the right side here, 5.5 million years ago to 1 million years ago. So CO2 is continuing to drop, and we're still in the process of the Isthmus of Panama closing off. As we go back, we're coming up on a period of time where now Greenland has an ice sheet and Antarctica has an ice sheet. The Isthmus of Panama is closed off and the Gulf Stream has been created. When the Gulf Stream was created, it started pumping warm moist water and moist air up into the North Atlantic. And that sent a lot of moisture over this cold part of the continents. And that increased precipitation, and that started the glaciers to build up on Greenland and subsequently North America, Europe and Asia. So we'll continue to go forward in time. Now right about here when Greenland picked up its ice sheet. Notice how the temperature dropped below today's zero average. So Earth's got colder. You still get a lot of fluctuations in temperature. That's due to glaciers forming, advancing, and retreating in the northern hemisphere. Now these cycles of up and down seem to be synchronized to something to do with the Earth's orbit called Milankovitch cycles, and they're basically happening at 41,000-year periods, and that has a lot to do with the change in tilt of the Earth's axis of rotation. So we'll continue going forward in time. We're almost to the beginning of this panel, and we're there now at period 1 million to 1,001,000 years in the past. Here we've advanced to the beginning of this panel's time period. This panel represents time from 1 million years on the right to 20,000 years ago on the left, almost 1 million years total. And you can see that the period of oscillation of the temperatures changed a lot. It's gotten broader, and these cycles are now running at about 100,000 years between peaks and valleys. Again, these are due to Earth's orbit around the Sun. These 100,000-year cycles are due to the eccentricity of the Earth's orbit. Sometimes the orbit is circular, sometimes it's slightly elliptical. And when it becomes elliptical, the climate becomes more erratic because the Earth can get closer to the Sun in the narrow part of the eclipse, and that raises temperatures and causes these dramatic changes in the temperatures. Now I want to point out that prior to around 400,000 years ago, and that's about here, the temperature of the Earth was running on average back and forth around almost 4 degrees below the current average. However, that average went up only slightly. But the range of variation changed a lot for the last 1 to 2, 3, 400,000 years in the past. The peak of these cycles, which are called interglacials. That's when the glaciers have retreated and the Earth is as warm as it's going to be. We're running 2.5 to 3 degrees above today's temperatures, and we drop down to where we were running on average 7 or 8 degrees below today's temperatures. The interglacials, and we're currently in an interglacial now, but the 4 that preceded the current interglacial were running a lot warmer than the one we're experiencing. Okay, we'll continue to walk back in time. Here I'm going to let the project run itself. Again, bear in mind that the average temperature of the Earth has been running colder than it is today. Okay, here we are about 400,000 years ago, approaching the 4th receding interglacial, where we're going to get a real warm period again. We're going to be running 2.5, almost 3 degrees warmer than today. Also keep an eye on CO2. It's been bouncing around the range from 180 during the coldest points to almost 280 during the warmest parts of the cycles here, and it's been pretty constant, and it's going to remain fairly constant throughout this panel's time range. So we're going to continue going back in time. Now here at about 200,000 years back we pick up our sea level curve. That's this guy here that's black over here. And I'm going to walk the X manually back here because I want to point out that during the last interglacial, which happened about 120,000 years ago, I'll stop. If I put the X over top this peak in temperature, there it is. You can see that the peak of the sea level curve right here is running 8 meters above today. 8 meters is about 26 feet. So that's a lot of difference. So sea level was a lot higher almost 120,000 years ago, and the temperature was much higher, about 3 degrees higher than it is today. Now from this point in time as we go forward we're going to approach the last glacial maximum, which is where the glaciers forming and retreating in the northern hemisphere their maximum extent. And so we'll go ahead and go forward, and we've ended up at the end of the first panel. We're currently sitting in the current ice age. Antarctica has an ice sheet. Greenland has an ice sheet. We're about 20,000 years in the past here. Temperatures cold, it's basically running almost 8 degrees below today's average temperature. From here to here the Earth is going to warm up over this about 10,000 year period because we're coming out of the last glacial maximum and we're going to be approaching the current period of time here, which is an interglacial, or essentially all the glaciers, except for the ice sheets over Antarctica and Greenland, have melted. So I'm going to go ahead and walk this forward in time. You can see as we do this the temperature starts out slowly rising, CO2 starts going up and sea level starts going up. And the sea level here goes up because the glaciers are melting. And I'll continue to walk us forward here. Now somewhere around 13,500 years ago something happened. The Earth started to cool again. No one knows why. We think it has something to do with the Gulf Stream, but we don't have any conclusive proof. But basically, instead of the glaciers melting, they started to advance again. The Earth cooled, you can see sea level rise leveled off. CO2 hasn't changed much, but for a couple thousand years things got colder and then something happened again and the Earth began to warm up quickly. Note that we reached the current temperature of the Earth right about here at 11,000 years ago, but the sea level still has a long way to go before it's where it belongs today. So if I take a look at where it is here, we're at 60 meters lower than we are today, yet the temperature of the Earth has reached our current level. So I'm going to go ahead and walk us forward, and there's another little dip here. And the reason we have a dip here is that geologically, the Earth was predicted to enter its next cooling period to start the next cycle of glaciation about 6,000 to 8,000 years ago, but that cooling never really got going. And it's speculated that this happened because of mankind's use of agriculture. There was no industrial revolution, so we weren't burning a ton of fossil fuel yet. But agriculture was taking off all over the Earth, and agriculture contributes CO2 to the atmosphere. CO2 can warm the atmosphere, and it's speculated that that warming helped offset the cooling cycle that would have started because of the next Milankovitch cycle. Anyway, we're going to go ahead and walk forward. Note that the temperature is pretty constant. There's not much apparent deviation. And when we reach the present, like I said up here, Earth is only 1 degree higher than it was between the average of 1960 to 1990. However, there was a spike in CO2 over the last 100 years, and that was due to the Industrial Revolution and a lot of fossil fuel burning all over the Earth. Sea level though hasn't really gone up very much. You'll notice here that it constantly went up and never stopped going up, and that was because of the way the glaciers were melting, and it's only up about 8 inches since 1900. To wrap this up, keep in mind that we are in a geologic ice age. We have ice caps on the north and south polar regions, and the continents have drifted many years ago into their current locations, although they're continuing to change. The change rate is very slow, and for the next few 100,000 or million years you probably won't see continental drift change make much difference in the Earth's climate.